Assalamu alaikum. Welcome to the second tutorial of our course Material Science for the Spring 2024 semester. You know that for the final exam, Chapter 1 Introduction, Chapter 3 Crystal Structure, and Chapter 6 Mechanical Properties are not included. So therefore, the midterm solution there is no need to discuss right now, right? Because midterm covered chapters 1, 3 and 6, and because they will not be included in the final exam, so we are not going to discuss them. We will directly go to the quizzes and so on. We will start with quiz 3, and as I mentioned earlier, whenever there are two sections, so then you are more lucky that you have questions from both the sections, so you have a larger number of practice problems. The first question always is the multiple choice and the true false. So this question, solidification of a molten metal happens at dash, right? Melting point, freezing point, equilibrium point. So obviously the correct answer is melting point or freezing point, because they are the same thing. Remember, when we are heating the material, melting point is the temperature where it starts to melt. When we are cooling the material, melting point or freezing point is the temperature where it starts to solidify. So the same temperature is called melting point or freezing point. Therefore this MP or FP is the correct answer. Next question, when two elements are completely soluble in each other in liquid and solid state, we have a dash alloy system: isomorphous, binary, multimorphous, tertiary, right? So tertiary, multimorphous is not definitely there. Binary could be anything which has two materials, but that is not mentioned here. The main thing is that they are 100% soluble in each other. So then it is an isomorphous system. Isomorphous, right? That it has, when they are 100% soluble in each other, then they will create only one solid phase in the end. So this is an isomorphous alloy system. Next question, the temperature and composition where liquid metal suddenly changes into two solids is this. Remember, a temperature and composition where liquid metal suddenly changes, right? So it is a triple point, it is a eutectic point, it is a double point. It is definitely not a double point, so that is out. It is a eutectic point, that is the definition of eutectic, that liquid suddenly changes into two solids. But also it is a triple point. This is very important. It is a triple point because there was one liquid on one side and two solids on the other side. So three stages, one liquid and two solids coexist at that point. So it is a triple point, right? So if you click eutectic point, you are correct, but you are not totally correct. If you click triple point and eutectic point, then you will be totally correct in this question. Next one, an alloy of eutectic composition freezes at a lower temperature than all other compositions. Just think on it or look at a diagram. Look at any phase diagram which contains a eutectic point. So to the left you will have liquid, then solid plus liquid, then solid. To the right of this you will again have liquid, solid plus liquid, and then solid, right? So if this is not the point, if you are not at the eutectic point, then to the left of this or to the right of this on the phase diagram, it will start to solidify at a higher temperature than this. But here at eutectic, all liquid suddenly changes into two solids, right? So this statement should be true, right? That yes, eutectic point is the lowest temperature at which the liquid starts to turn into a solid. Next question, non-equilibrium solidification of liquid metal leads to cored structure, right? So definitely, right, if you know this part, then definitely true, isn't it? Because if it is equilibrium cooling, then there is a homogeneous structure everywhere. If it is a non-equilibrium cooling, which generally means faster cooling than equilibrium, then some cores are formed in some places and it is a cored structure. Okay. One more. After the process of homogenization, cored structure is formed in metals and alloys. So I have already showed you the answer by mistake, but yes, you see, after the process of homogenization, all the cored structure goes away, isn't it? Homogenization is the process, the heat treatment process, which is done so that the cores are removed and the material becomes homogenized again. So therefore this statement is false. After homogenization, the cored structure will not be there anymore. Okay, so these were some of the multiple choice and true false belonging to quiz 3. And of course this is the same for both the sections. Let us move on. Let us now move to question 2A of section 10 for the quiz. The question was, name and briefly describe the important lines in the phase diagram of a binary eutectic alloy. So what is the answer? To answer this, it is easier for me to first show you any sample. This is a lead tin diagram and the phase diagram is shown because this is a binary eutectic alloy. I could have taken any other example also, but this is a binary eutectic. So what are the important lines? Liquidus, right? The liquidus line, which is here and so on. Solidus line. This is the solidus line, that is the solidus line, and this is the solidus line. Solvus line, right? Solvus, one side one solid, the other side two solids, and solvus line on the others. And of course tie line. Anytime you have to draw a tie line between two temperatures. So 3 lines, the liquidus and the solidus and the solvus are in the diagram, and tie lines are what we do. And then briefly describe, yes, liquidus is the line where above it you have only liquid, below it you have liquid plus solid. Solidus is the line above which you have liquid plus solid, below it you have only solid. Solvus, as we just told you, is the line where on one side of it we have a single solid, on the other side we have two solids. And tie line is a horizontal line so that it cuts liquid or solid and so on, and you find out and use it to find mass fractions by the lever rule and so forth. Let us now move to question 2B of quiz 3 of section 10. The question is, name the type of the phase diagram shown below. Perform phase analysis for a 40% tin alloy at eutectic plus delta T temperature and at eutectic minus delta T temperature. Fortunately or whatever, the phase diagram is a lead tin diagram, which we just discussed as a binary eutectic diagram. So as I always encourage you that this is a tutorial and this video is available for you to see time and time again if you want, but pause yourself here, don't look at my solution, resolve it. You have solved it once in the quiz, but solve it again, and once you are very sure, then go to the solution. Just a small note from my side, I always tell you that either I am solving it in the class or doing it as a video tutorial. This is for you to practice for the final exam. So you have done this question in the quiz, and here I am totally going to solve it for you, but pause the video lecture right here, take out your pencil, paper, whatever, and solve it. Don't give up. It is a very simple thing. You have been doing similar things too many times. Solve it, and once you are sure of the solution, then only go to the next page. So let us proceed with the question. The first part, 40% 10 and eutectic plus delta T temperature. So I am just showing you on the short side this diagram, and it is 40% 10. So you draw a vertical line here, and it is T eutectic plus delta T. So this is the eutectic temperature. So you draw a line just above it, right? So if you have drawn the tie line, suppose this is the tie line. So on the left of the tie line is alpha 18.3. In the middle of the tie line, W naught is 40% 10. And at the right of the tie line, it is liquid at 61.9% 10. Right? So this is your detail. And if you have the tie line, then the rest of the things are here. Phase analysis means all the things are required. So what are the phases present? Liquid and solid alpha. What are the compositions of the phases? Liquid at 61.9% 10, right? Liquid at 61.9% 10, and solid alpha at 19.2% 10. Now, just a small note that when I was solving this, then I took a diagram of lead 10 where this value was written 19.2. But in your diagram, if it is 18.3, then read 18.3 here. Otherwise, the rest is okay. Of course, after that, right, phases present, compositions, and then the mass fractions of the phases. So you use the lever rule, but because the tie line is there, so there is no issue. Weight percent liquid, right? Weight percent liquid. So liquid is here, so go to the other side. Go to the other side, right? So if liquid is here, go to the other side. 40 minus 18.3 divided by 61.9 minus 18.3. Here I'm using 19.2, just change it and do it and so forth, right? So this is it. Similarly, weight percent alpha or mass fraction of alpha. So alpha is here, therefore go to the other side. 61.9 minus 40 upon 61.9 minus 18.3, and then you will have it, right? So this is how we solve that. When we say do phase analysis, then phases present, compositions of phases, amounts of phases. What is the last thing there? The structure. So remember that when you are doing a structure, the structure here, right? You are here, so it is all liquid. When you touch this line, alpha starts to form, more alpha, more alpha, more alpha. There is lots of alpha there. So, right, what will be the structure? The structure is now shown here, right? The structure is shown here. There will be liquid and there will be alpha, but it is pro-eutectic alpha. This is very important because this is the eutectic line. This alpha is formed here. This is not the alpha below it. So pro-eutectic alpha. Of course, you don't need to write the values. We are writing values here, but you don't need to write that. We are continuing the question. So this time it is the same 40% 10, but at eutectic minus delta T. So once again, the diagram is given, but now the important thing is that this vertical line is here, but the horizontal line is just below minus delta T. So on the left, it is still alpha at 18.3. In the middle, it is still W naught at 40. But on the right, this time we have beta at 97.8, right? So this is very important. And then, right, just what are the phases present? What are the compositions of the phases? What are the amounts of the phases? Again, remember, instead of 19.2, use 18.3. And finally, what is the final structure? So this time you will have pro-eutectic alpha, and here you have eutectic alpha and eutectic beta, right? So remember that this time, sorry for the diagram is slightly shortened, but eutectic alpha plus eutectic beta and pro-eutectic alpha. But the question is very similar always.